For all the incredible things AI can do, there's this one single flaw that holds even the most powerful models back. It's kind of like digital amnesia. But what if Google just found the cure? We're going to break down exactly what this problem is and why this potential fix is such a huge deal.
All right, so first things first, let's really get our heads around this digital amnesia. It's not just some minor glitch, it's a fundamental problem, a real roadblock that's stopping even the biggest, badass AIs from getting to that next level of, true human-like intelligence.
And it all comes down to this really simple question. Think about it. You and I, we learn new stuff every single day, right? And we don't forget what we learned yesterday or what we had for breakfast. But for an AI, oh man, it's a completely different story.
So the fancy technical term for this is catastrophic forgetting, and it's exactly what it sounds like. Imagine this. You spend months training an AI to be a chess grandmaster. It's brilliant. Then you decide to teach it checkers, and in that process, poof, it completely forgets how to play chess. Gone. Every single time you try to fine-tune a model on something new, you're basically rolling the dice, risking wiping out everything it already knows.
And listen, this isn't some minor nerdy issue we're talking about. We've got heavy hitters like Andrej Karpathy, one of the co-founders of OpenAI, calling this one of the biggest roadblocks to AGI. He's basically saying, look, you can make these models as massive as you want, but if they can't learn continuously, they're always going to hit a wall.
Elon Musk has talked about this too. He's stressed that for AI to ever get truly smart, it has to be able to learn on the fly, immediately, just like a person does. But, up until now, that's been more of a sci-fi dream than an actual reality. So, okay, if the current AI architecture has this massive flaw, where do we look for a better design? Well, the answer is kind of staring us in the face, or more accurately, it's right inside our own heads. Let's talk about the human brain, because it's the ultimate blueprint for learning. I mean, when it comes to learning new things and just constantly getting better, nothing beats the human brain. It's the gold standard. That ability to adapt, learn, and remember, all without just overriding old skills, that's the magic trick AI researchers have been trying to copy for years. And look at this comparison, it's just night and day. Our brains have this amazing thing called neuroplasticity. They physically rewire themselves as we learn. But current AI, it's basically built on static knowledge. It's rigid. To learn something new, you have to do this massive, full-scale retraining that, you guessed it, pretty much wipes the slate clean.
And that's exactly why the amnesia analogy is so perfect. An AI's knowledge is split into two completely separate things. You've got this temporary, short-term memory, the context window, and then you have its permanent, pre-trained memory. There's just no middle ground, no way for new, lasting memories to actually form.
Okay, but this is where the story takes a really exciting turn. Google just dropped a research paper with a proposed solution that, it could genuinely change everything. They're calling this new approach nested learning.
And the main idea behind it is actually beautifully simple. Just picture this, a brain made of many brains. Yeah. So instead of one giant monolithic system trying to do everything all at once, it's more like a collection of smaller, specialized systems all working together in harmony. Okay, so here's the nuts and bolts of it. Nested learning completely rethinks what an AI model is. It's not one thing. It's a bunch of smaller learning systems or optimizers, all nested inside each other. Now, here's the cool part. Some of these little brains learn super fast, adapting to new info in real time, but others learn really slowly, holding on to that deep foundational knowledge. The whole structure is designed from the ground up to stop that catastrophic forgetting we were talking about.
And right here, this is the really radical shift in thinking. For like ever, AI research has treated the model itself, the neural network, and the process of training it as two totally separate things. But Google's paper basically asks, hey, what if they're the same thing? And that is a huge deal. It means the model isn't just learning facts anymore, it's actively, continuously learning how to learn.
Okay, so that's the theory. And it sounds amazing, right? But how does it actually work in practice? Well, to test this whole idea out, Google had to build a brand new model from scratch. Let's take a look at how their HOPE model works.
Let's just quickly walk through how it's put together. First, you've got those nested systems, all these little learning loops working inside each other. And the key thing is, they all operate on different time scales. You've got your fast learners and your slow learners. This mix creates this really layered, resilient memory system. And the end result of all that? The model can finally adapt and bring in new information without wiping its own memory. Now, to put a new idea like this to the test, you can't just tweak an old model. Nope. Google's team had to build a totally new architecture from the ground up. and they gave it a pretty fitting name, Hope.
So Hope is what's called a self-modifying model. It's kind of an evolution of an older architecture they had called Titans. But here's the difference. Titans was stuck with just 2 levels of learning, a really rigid short-term and long-term memory. Hope, on the other hand, can have a potentially unlimited number of these nested levels, and that's what lets it constantly update not just what it knows, but also how it learns.
So the million-dollar question, did it actually work? Well, the results kind of speak for themselves. On a whole bunch of benchmarks, the Hope model just flat-out outperformed other architectures like Titans and Mamba 2. It showed lower perplexity, which is just a fancy way of saying it was less confused. Plus, it had higher accuracy and was way better at reasoning over long streams of information.
And get this, in those really tough needle-in-a-haystack tests, where you hide one tiny fact in a mountain of text and ask the AI to find it, Hope performed with almost perfect accuracy. That is a massive leap forward. It's a real demonstration of an AI that can recall specific details much, much more like a human. So what does all this mean for the future? Is this the big breakthrough that everyone's been waiting for? Let's zoom out a bit and think about the bigger picture here.
Really, the biggest takeaway is how this new idea from Google merges the what with the how. It stops treating the model's design and its training process like 2 different things and instead combines them into one single dynamic system. That conceptual shift, that could be the key to finally solving AI's amnesia problem.
The researchers themselves said it best in their paper. They said this approach offers, and I'm quoting here, a robust foundation for closing the gap between current LLMs and the remarkable continual learning abilities of the human brain. I mean, that's a pretty bold claim, but a powerful one.
Now, let's be clear, this research is still super early. The performance gains we're seeing aren't, world-shattering, at least not yet. But the shift in thinking is a huge foundational step forward, which leaves us with the big question, right? Is this the real deal, a genuine leap on the path to AGI, or is it just more hype? I guess, for now, only time will tell.